Let's talk about promises. Promises async await. Most guides and articles explain how to use them, but I want to explain you the essence. Why do we have them in the first place? So let's take a simple task. We want to do 5 steps: connect a database, query user, some data user, and then update an external service, and then log a line. What's the difficulty with all these steps is that if the last one is considered kind of simple and immediate, the rest of them take some operations that we don't know how much time will take. And in JavaScript, we cannot wait for the slow operation. We have to use some tricks to release our process, our main command flow, where we execute our current code. So what did it look like in the past? When I started using Node and even earlier with JavaScript, we used callbacks for that. So you have your fancy database library. You can request the connection to the library. This connection could take time. So you cannot continue immediately to work with that handle, and you have to pass a function there, a callback. I'm not using arrow functions because I'm talking about the year when we had no arrow functions in JavaScript. It looked like this, and you have to wait for the result to get either a connection or an error, and then to handle error. But that will happen later. And if you add some console log, whatever, then you will see that first this line is executed, and only then this line is executed. Maybe the better place to show it is here, because we don't know, is it an error and error. So first JavaScript executes everything in the main flow function operated by operator. So you see this operator executed first, and then when the connection happens, it executes the callback that we've passed there. All right. So we've implemented the first step. The same goes. So we implemented the second step here. We query users, and now we have users. Here we can continue. And we implemented the third and the fourth steps. And we see it is the padding on the left is increasing and increasing and increasing. And this is not quite a comfortable situation. It causes some confusions. Basically, you should avoid deeper nesting everywhere, including in the if conditions, because again, this is a source of confusion. And of course, people were thinking about what to do with this nesting, how to reduce it. And the concept called promise was invented. If you compare these two implementations, not like that, not here. So we still connect the database the same, but we don't provide a callback immediately. Instead, we agreed that this function, every function that needs us to wait for it, is providing a special object called promise. And that object is basically defined as just an object that has then method that accepts a function, a callback. That's the very original definition of promise. Later, the capabilities of promise were extended, but originally it looked like this. And why that? Because in this case, we can define chains, by the way, then should return another promise or the same promise, doesn't matter. If it can return the same, it returns the same. If it cannot, it returns different. But that's not interesting for us. The interesting thing for us is that if we define a chain like that, then every further callback will be called only when the promise returned from the previous callback is resolved. And that means here that this callback will happen only when this is resolved, and this will be called only when the connect is resolved. So it contains the output of the previous method. And the same users, we've got it there, and now we are getting it as the only parameter. That simplifies things because the error handling is moved into a separate method, into a separate callback identified with the catch call. So we still have the same execution of JavaScript if we add console log here and console log y there. This one will be executed first because we go in the main flow, and only then we enter the functions, and this will be executed second. However, all our operators are looking like a sequence now, pretty much the same as we originally did. We want just a second sequence of steps, and now we have that sequence, right, at the same level, except the very first operator. And we are trying not to notice that we have lots of garbage, the mandatory garbage in between our operators. By the way, there are no error here. And there goes the response because it is post, as we agreed previously. Then, what's going on further? Then people invent a way how to hide this. Keep the mechanism itself, but keep this garbage under the hood. And so the async await was introduced. Now we have this, right? I probably prematurely close the window because we want to compare this. So here we have explicit promises with them. And here we have the same operations. Fancy, why did I type it differently? The same operator, fancy DB connect, the same operation, connection query with a single parameter, the same operation, connection execute. It is identical. The only difference is that this part, along with return, is hidden inside this keyword. So this executes the same. However, you could see that the console log is in the end. And when I previously added console log in the end, I told you that it will be executed first. That's no longer the case, because right now, the very first code block that was executed, that is executed first. Previously, it was the whole root level without the functions. And now it ends on the first await. So we enter here, we see a command, then we see the first operator. After this operator triggers the await, and that's all. We no longer have the script where we entered the execution. A parallel process is running, and the rest of the script, this part and this, is waiting, is hanging up somewhere in the memory. So if we have global variables, the value of a global variable could be different here and here. And that's impossible without the explicit nesting there. All right, let's skip that details, but now we have a chain of functions like this, but it is still a chain of functions. The parts between the await splitting are still executed as an independent functions. However, the difference that all this is written as the consecutive algorithm. What do we miss here? In many cases, you cannot use await without the special context in the async function. All right, I've skipped a bit. What do we miss here as well is the error handling. Here it is. We now can use the try-catch syntax, the ordinary try-catch syntax, and it will work exactly the same as we saw here. But the only difference is that it is looking prettier now. And the next thing I wanted to mention that now on the front end and in the older versions of Node, you can use await only inside the async function. That's because the root context doesn't have any idea about your exception handling, and you have to do it yourself. And after that, you can just run this function as a simple function. And again, a console operation here will be executed before the contents. Actually, this is going to be interesting. Here, 1, then we enter our function before the connect 2, y, and z after the await. So the order will be, we enter run, we reach this point, we are executing everything up to the first await. So first on the screen, we will see y. Then we quit this function and continue. So next we will see xxx on the screen. And only then, when the asynchronous operation will complete, we will continue this part between these two awaits will be called as a separate function, and we will eventually see the part. So first run, executing this part as a separate function and see y, executing the next operator see xxx, and after we see that without a pause. And after a pause, whatever it takes to connect, we see z appears on the screen. Oh, what else? Why that's strange? Here we could see that WebStorm shows promise return from run is ignored. That means catch here is not handled. Of course, we know it is handled inside. So there is another form to write the same and get the prettier function. Just compare these two. So here we have a function, a try-catch block, and the algorithm. Here we have an algorithm in a separate function and an error handled again separately. Now I'm using error functions because we are in the future. We have async, we have await, we have promises, and we have error functions. This could be a standard handler, separate function, whatever, but you have much better control of how your code looks and how your code feels, how easy it is to read it. A simple sequence is better than something nesting with questionable control flow. Here, you just don't think about error handling. You know that you rely on the exception throwing algorithm. And you are sure that somewhere you have a catch-all handler. So unless you need to handle any specific error, you can just forget about the error handling within this context, just because you know you have the error handling properly implemented here. But this doesn't mean this way is better than that. you think what to use. But let's move on. Next, we could see that in the, I have no idea what am I doing. Close all the tabs. Let's return to the callback story. What if we want to execute this operator and this without waiting one for another? Maybe they're both slow and their inputs are independent one on another. In this case, it is user ID and it is constant. So we can send the request to the database server and be waiting for the response. And without waiting for anything, we could send, okay, let me say this again. So we can send a request to the database server to initiate this command. And without waiting for anything, we could send another request to the external server. And only after that, we have to wait somehow to show this message after, only when both are successful. In this case, it will be executed immediately without waiting, and I won't be showing you what we did in order to solve this problem, because in the modern world, it is looking way simpler. So the same as we did in the past. Let me also show this comparison. This is how we do it with callbacks. We no longer call post within this callback. Instead, we call it at the same level with execute. And so the asynchronous operations are being processed in parallel in the same time, independently. Then this is what our algorithm looked with the consecutive execution, and this is what it looks like when we attempt to execute these operators in parallel. The difference is here. We remove this await. Instead, we remember this promise, and we replace these operators that gets the output and await again. We replace this whole part with saving another promise. And then we call await promise all and pass these two as an array into this method. So we are awaiting for them both. This promise all means exactly what it says. It is promise for this all. If any of these triggers, this is still waits and waits. And only when all of them are resolved, only that resolves the whole thing here. And we could also extract the data from them in order to use it further. And also I wanna mention how to use promise with repeatable operation with arrays. For example, we have here an array of users. What if we want to do some operation on every user independently? And we want to do that in parallel. So we want to spawn all these updates in the same time and then wait for them together. We can do that. We can use the map function. So we are mapping the user to every user object to a promise that is the result of this operation. And then we are waiting for all of them. We are transforming all these individual promises from every update into a single one, and then awaiting for it. Good. That's all for today.